Welcome everybody to this webinar on all-weather operation. My name is Francisco Arenas. I am the project manager of 379 all-weather operation. Welcome to this webinar. As I said, we have many people joining us together in this webinar. And so we're going to start now. I'm going to give the floor to John Franklin, Head of Safety Promotion, to give you some rules of the house. And then we will proceed with the webinar. Welcome, everybody.
Hi, everybody. Thanks for the introduction, Francisco. My name's John Franklin. I'm Head of Safety Promotion here at EASA. Just a few kind of initial housekeeping things. So we're going to be using Slido for the interaction and the question and answers. So if you haven't found it already, if you're connected via the WebEx in the bottom right-hand corner, you should see apps, and then within the apps, Slido, and it should come up in the bottom right-hand corner of the screen there. And then you can ask questions, you can upvote questions, etc. Another option you have is to go to slide.do on the website, and then it's hashtag AWOEASA. I've put it in the chat in both the session, so you can see it there. And then the passcode again, I put that in the chat, but it's 6E2IZL. And if you see that, you'll see they're in the chat, both in the YouTube and the WebEx. Particularly if you're in the YouTube session, so we've had an overflow into YouTube. If you have any problems, you can use the chat to talk to us in the team here. Failing that, please put the questions, if you're in the YouTube as well, in the Slido through the web browser. So hopefully that should work quite well. Other than that, we've got all the different presentations, all the experts. Hopefully you'll have a really interesting discussion and have a really enjoyable session. All of the presentations, all of the material afterwards will be posted both on the Together for Safety YouTube channel and on the AirOps community. Probably on Monday, we'll send an email to everybody that participated and registered with the links to all of the material so that you have access to everything. So yeah, everything that you'll see here will be available afterwards. So no need to check and ask about that. So thanks very much. Without further ado, I'll hand over to my colleague, Micaela Verissimo, who's the section manager for air operations.
My job here today is actually just to welcome you, and it's a great pleasure to do that. I would like to particularly extend a warm welcome to the colleagues from authorities and industry that are going to join us today as presenters and panelists. And I'm sure that this will be much more interesting with you participating together with us. And to all the participants, well, we organized this event to share information with you that we hope is going to support you in implementing the upcoming all-weather operations requirements. But the good implementation of the rules requires not only good knowledge of the rules, but also concrete operational experience, and your participation is therefore essential to us to make this event a success. And that's why I'm so pleased to see that so many of you have joined us, both from authorities and industry. I have joined the air operations section not so long ago, but this is actually a project that my team has been working on for more than 7 years. And we've been working on this for a very long time with the support of experts from authorities, from industry, and it was a real multidisciplinary project at EASA, which affected 4 different rules and different categories of stakeholders. A lot of the work that we did also took place at ICAO level because we wanted to try to achieve the highest possible degree of harmonization at international level. When we started working on all-weather operations, our main objective was to modernize the legal framework that applies to these operations to enable efficiency gains based on latest technology and, of course, always maintaining a high level of safety. And at the end of these 7 years of work, what we achieved is a result, a set of performance-based and technology-neutral rules that will not only enable the use of existing technology, but facilitates the introduction of future technology developments. And this was not something that was easy to achieve, but it was, in our view, essential to try to bridge the unavoidable gap that always exists between the pace of operational reality and technological advancement and the slower pace of regulatory intervention. The changes that we are introducing with this package will enable more efficient operations, making available a wider selection of aerodromes, and we hope that this will contribute to a more sustainable aviation by decreasing fuel intake, operational disruptions, and environmental impacts. Over the next hours, you are going to get an overview of the changes introduced that is going to be given by my colleagues in EASA from the areas of operations, certification, and aerodromes. You will also hear from colleagues from authorities, operators, and manufacturers that work closely with us on this project and will share specific insights into the new framework. You will also have the possibility to ask us questions and participate in the discussions with EASA and with a panel composed of authorities and industry representatives. And we are really looking forward to your insights and active participation. I wish you all an extremely interesting and successful afternoon.
Thank you very much, Micaela. So now we're going to continue with the workshop. The most important element to start with is going to be. Second, I am having some issues. Okay, it's going to be the agenda for today. The agenda for today is going to be a first session, this session of 45 minutes approximately. We're going to give a general overview of the total system approach already introduced by Micaela, and we're going to give you what was on the background and what was, in our minds when we have to continue with progress with the rulemaking task 0379. Then Carl is going to give us an overview of the certification amendments. CS issue 2 was published on the 30th of March 2022, and he will provide us an overview. Then we will continue with aerodromes. Regulation 208, Vasileios, I think it is correct, 2022 was published also this year, first quarter, and he will provide us an overview of the implementing rules plus the AMC and GM material. And finally, I will continue with an overview of the OPS regulatory framework that will include, of course, the all-weather operation, but also I will try to focus on at least spend one page on helicopters changes that are also important. So that will take us about 45 minutes. So it's going to be until 2:30 local time here in Berlin, Madrid, Paris time. And then we will have a small break and we will progress with a second session on a stakeholder view, starting with Stephano Prola, and then with Karsten Nilt from LVA Germany, and then some other two colleagues from the industry, Thierry Bourreau from Airbus, and a practical example on the desktop assessment performed by Valentin. This is going to take approximately, the practical example is going to take about 25 minutes time. So we hope that in 1 hour, 1 hour and 5 minutes, we should finish, and we're going to have another break at 3:30 local time here in Germany. Finally, we're going to have a panel discussion of about 45 minutes. For that purpose, we invite you to now file and make all the questions you need in Slido. John has already provided the link. Please write, type your questions. We will select the most popular ones, and we cannot expect to answer all the questions. We already received a number of questions before the webinar, and we will expect to receive, probably normally with this kind of events, we receive between 200 and 300 questions. Obviously, we only have 1 hour, 45 minutes time, so it's going to be very difficult to answer all of them. However, we will try to answer the most appropriate one and the most important one appropriate in terms of transferring the knowledge of the regulation. We have a number of participants. I will introduce them later, just before the break. And that's going to be the agenda for today. Again, I remind you, please write your slide of questions application, and we will select most of them, or try to answer most of them. So let's start with the first presentation, all-weather operations general overview. And for this, I want to touch on what Micaela has said. When we started this project, we saw already back in 2016, 2015, that the technology was developing very quickly, and we had to ensure a regulatory framework that allows, in one hand, legal certainty, etc., but on the other hand, to foster the innovations of the industry. I am just putting some of the most interesting ones, like SVGS, Enhanced Flight Vision System, etc. But we are receiving everyday applications of new technologies with microwave, instead of the infrared, with microwave sensors. We are receiving, of course, a lot of applications regarding the synthetic vision system, etc. So our idea was, in a nutshell, to have in the AWO project a total system approach. And from that moment, we thought that it was important to combine in a single rulemaking task all the domains of the EASA, starting with air operations, but also in terms of piloting, pilot training, etc., through our colleagues in flight crew licensing. Also, the aerodrome infrastructure, which plays a significant role in the use of all-weather operation. And finally, initial airworthiness certification, which enables and are the original equipment manufacturers that put that technology into the operation. So again, our idea was to ensure a total system approach. At that time, Marcel Compare, who is now retired and he's here, we give him a hello for him. Started this project, and Willie Siegel, and then I took over 3 or 4 years ago this project management, and since then we continue this idea of the total system approach. That means that we changed slightly the approach. Originally, in the current regulatory framework, we had a very prescriptive implementing rules with very prescriptive ops rules, in which, for example, the enhanced flight vision system was only crediting 1/3 of the visibility. Those kind of rules are being removed and pushed into certification. So it will be the manufacturer, it will be the original equipment manufacturer who will determine the possibilities of that equipment through a new certification rules. That allows to improve and to foster new technologies, because the original aircraft equipment manufacturer knows that their limitations and the improvement of technology will be immediately transferred into the operations, where the ops rules have no limitation, provided that the equipment is being certified. At the same time, we do that in the same way with aerodromes. So creating a regulatory framework that, in a voluntary basis, allows the aerodrome operator to introduce new technologies, while in ops, again, there's no prescriptive limitation. So the technologies implemented at aerodrome level can be automatically be used by the airlines. So let's talk a little bit more about what we mean with performance-based regulation and total system approach. So the performance-based regulation means that the safety objective should be in the implementing rule, and it should be technology neutral, technology agnostic. and the technical requirements should be in the soft law. Today, you see in the regulation that we have, for example, the technologies, specific technologies like ILS, GWAS, or EFPS. All of them are in the implementing rule, and therefore impose a limitation and impose a prescription in terms of technology. So the new regulatory framework has no technology description at the implementing rule level, meaning that you will see now in the new regulation the term XLS. So, for example, which means a landing system that is not bound for a specific technology. And then later on in the AMC, you will see that there where we have the technology, the ILS, the GWAS, the EFPS, etc. Therefore, the affected regulation, with this idea in mind, we assess the combination of risk, and for that, you can see in the concept paper of the all-weather operation, very detailed risk assessment that we did together with the concept paper. You can go to the EASA website, look for 2015 terms of reference, and you will see the concept paper and the idea behind, with a very detailed risk assessment performed by Willie Siegel and his team regarding this total system approach that I am referring to, in which aircraft, ground infrastructure, and approach minima is, let's say, combined. And if we have an enhanced aircraft with an enhanced ground infrastructure, that means that we can use and reduce the approach minimum. The other way around it works with an advanced aircraft and little ground infrastructure. We could provide a standard approach minima, or even improve the approach minima that currently we have, like, for example, with the SA Cat 1, which is a technology that allows in a Cat 1 environment, airport environment with ground-based equipment on Cat 1, be able to have an approach minima close to Cat 2, provided we have an advanced aircraft. That's the idea of the total assessment and the total system approach, the assessment and combination of all these technologies. Finally, that means that obviously requires the certification of OPS and FCL and aerodromes, and the regulatory frameworks affected are therefore 965, 1178, 139, and the CS8WO. In terms of the stakeholders, all the stakeholders are involved: aerodrome, helicopters, including CAT, NCC, NCO, and SPO, and ATOs, aerodromes, and aircraft manufacturers. So with no more delay, I'm going to pass the floor to my colleague. Sorry, one more element to describe. It's about the entry into force. As you can see in my page, the original aircraft manufacturers already have a regulatory framework that will allow 6 to 9 months time to develop the new regulatory to develop the new equipment and update the necessary documentation. Then the aerodromes will kick in on the 1st of August, and then finally the OPS and FCL. But at that time, all the other domains should be ready to receive their operations on the 30th of October 2022. So I give the floor now to Carl Garvie.
Thank you, Francesco. Those of you who don't know me, I'm Carl Garvie. I work in the Certification Directorate as a Regulations Officer responsible for initial airworthiness. I have a portfolio of various different CSs, but in particular today, I'll be talking about CS all-weather operations. As Francesco mentioned, as part of this holistic rulemaking task, we're also addressing the certification aspects as well as the other domains. And you'll notice that the focus has shifted slightly from the operational approval now to the initial airworthiness approval. And so it was the right time to update CS all-weather operations. So I'll just talk briefly about the initial issue of CS all-weather operations. Those of you who are familiar with the JARs, it started with JAR all-weather operations. In 2003, EASA took JAR all-weather operations. There were some outstanding NPAs, notice of proposed amendments. We took those and we incorporated those into issue 1, the initial issue of CS All Operations in 2003. Unfortunately, that's where it stayed. There was no further updates since 2003 to the CS All Water Operations until this rulemaking task started. There was some initial JAA MPAs which were not incorporated into the initial issue. So we started with those and incorporated those into our working draft of CS All Operations. For example, heads-up displays, auto brake, and super fail passive systems. Another important element is because of the lack of updates to CS All Operations, we had to have special conditions, which we included in CREEs, certification review items. These are the deltas to the initial issue. So in the meantime, we've been working with these CREEs because we hadn't updated CS All Weather Operations. So we had to incorporate those into our initial draft as well.
They say that the sound is...
I can use my own microphone if you like.
I will mute this one here and you have yours.
Okay.
Hear you at all now.
Okay, hopefully that's much better now. I have the audio using the headset. So I was talking about the initial structure of CS All Operations. Originally, there was 4 subparts to this CS. We had the first subpart for automatic landings, subpart 2 was for Cat 2, subpart 3 for Cat 3, and subpart 4 for takeoff in low visibility. And as Francesco mentioned, we wanted to be more technology agnostic and allow for updates to technology in the future. So we completely restructured the CS into different subparts. So in subpart A, we've extracted all of the technology dependent elements, and we put them into a subpart which we've called enabling equipment. And as technology comes on board, we can update this subpart and add different sections to this or amend them as necessary. For example, we have the original automatic landing systems, but we've also added HUDs, enhanced flight vision systems, synthetic vision guidance systems, and combined vision systems. Now in subpart B, you'll see this is where we've put the performance-based elements. So there's no technology focus within subpart B. It provides you the performance requirements for the systems. So at section 1, we have Cat 1. Section 2, we have SA Cat 1, which is new. And section 3, we have Cat 2. And section 4, we have Cat 3. And section 5, we have reduced visibility for operational credits. And in subpart C, we have retained the takeoff operations in low visibility. So you can see in this way, we're able to very dynamically update the CS as new technology comes on board, but retain the performance requirements within subpart B and have the more prescriptive parts in AMC. So what's gone into CS All Operations Issue 2? Although it's considered perhaps older technology, we've included heads-up displays and heads-up display landing systems, which we've been using certification review items for some time now, and we've formalized those now into the CS. And it's based on the old NPAs from the JA and also experience from projects over the last 15 years. The next element you'll see, which is an important one, is the enhanced flight vision systems. The requirements for this we've based closely on the FAA Advisory Circular 167 Bravo to try and get as much harmonization as possible. We've also taken inspiration from DO 315B as well. And also we're referencing out to the performance requirements for the visual advantage standard. So we're hoping that we'll get standardization and harmonization with our certification partners throughout the world, so that we have a standardized approach to determining that visual advantage. We've included both EFVS to approach to 100 feet and also EFVS landing systems. And that visual advantage that is gained from the certification will be published in the AFM and allow the operator to make those decisions on the performance of the system. We've also included synthetic vision guidance systems, which are, we have a number of applications ongoing. And the requirements for, we've taken inspiration from DO 359. And we've also included the combination of those two in CVS, combined vision systems, are also included in CS Forward Operations Issue 2. One of the important elements of this CS update is to look at also what's going into the OPS regulation for SA Cat 1. And we take the certification requirements from Cat 2 and looked at how we can adapt those to SA Cat 1 operations. Any specific limitations that are on the system because they're using Cat 1 ground systems, those limitations will be contained in the AFM and allow the operator to make those decisions on how best to have operations to those particular runways. We've got example technologies within the AMC to this section. Again, they are examples because as long as the system can meet the performance requirements, it could be eligible for SA Cat 1. So some examples, we have HUDs or equivalent systems with flight guidance that comply with the performance requirements, SVGS that are able to meet the performance requirements, automatic approach systems that are combined with a HUD. They're used then to monitor the flight path and control after decision height. We've also, as an example, there could be an automatic landing systems that's able to comply with the performance requirements, but still using a Cat 1 facilities. Automatic landing systems with a HUD in order to help the flight path monitoring before and after decision height, and any other flight guidance system which is able to meet those performance requirements. So you can see we've really made this quite flexible by stating the performance requirements in the CS and leaving the applicant then to try and find a suitable system to meet those performance requirements. And then any limitations are then published in the AFM. So with that in mind, that concludes the presentation on CS All Operations. Again, very top level, but hopefully very interesting for this forum.
Carl's microphone.
It has to be connected. It's not
No, no, but it's connected in his computer, and you move here.
Okay.
Okay. Can you hear it now? Okay,
Okay.
so
So
Okay, works now, yes.
okay, so sorry for this problem. For the aerodromes, so we were part of this project, and our objective was mainly to support the introduction of these new technologies, and the reasons for the change. First of all, we had to align with ICAO Annex 6 and Annex 4 and 14, and also to consider the provisions in the all-weather operations manual by ICAO. And as I said before, to support the implementation of all-weather operations by ensuring the availability of appropriate visual and non-visual aids. Another important thing is the availability of information in regards to the aerodrome infrastructure, which is available to support this type of operations. And of course, also to implement the appropriate procedures. And in Regulation 208 of 2022, well, there were some changes. I have to say that there were not so many changes, but they were mainly on three parts: on the definitions, where we had some changes in the definition of the decision altitude, decision height, low visibility operations, low visibility procedures, and low visibility takeoff. These were mainly to have some consistency with air operations regulations. We have also included the operations, the definition of the operation with operational credits, which is also coming from ICAO, but we also aligned with the air operations. And we changed also the definition of the instrument runway. And for those who are aware of the ICAO changes on the definition of a Cat 3 runway, we don't have anymore the three subcategories A, B, and C, but we have only one category 3. On the organization requirements, we have extended the responsibilities of the aerodrome operator, or mainly we have put in the regulation what was the current practice, because an airport is not only the runway and the physical characteristics or the lights. To support the operation, you need also to have the appropriate nav aids and met equipment. All these things are required. And since the aerodrome operator is responsible for the operation of the aerodrome, it has to make sure that all these things are available in order to contact the information. On the operational part, the changes are in the aerodrome data part and on the operational procedures. And there we have in the aerodrome data part, we have included new requirements which either they are stemming from ICAO changes, for example, the information on navigational aids. The current provisions did not have so much information, but with the latest change in PANS EAM, there is more detailed information on the navigational aids available at the aerodrome, and you will see that this information is very important for the air operators to conduct the assessments. We have also information a requirement for the publication for the origination of data which are required for the charts. We know that, well, charts are already there, but still there's no obligation for the aerodrome operator to originate the data needed for these charts. And also we had new requirements about the penetration of visual segment surface, which is also very important for EFES operations mainly, and is coming also from a change in PANS AIM. And last but not least, the information on the type of visual aids, and especially the existence of LED lights, which have an effect on EFVS operation. On the operational part, we changed two things. It's the SMTCS rule and the low visibility procedures. Where I will say a little, I will refer to this a little bit at the end of the presentation. Now, to understand the concept, first of all, we need to know what is a basic principle. The basic principle is that whenever we have an operation where let's say the decision height is below 200 feet and or the RVR is less than 550 meters, we require low visibility procedures with the current system. And this mainly applies to Cat 2, Cat 3 runways. There are additional requirements about the radio altimeter, which also requires precision approach terrain charts, Cat 2 instrument approach, Cat 2 or 3 instrument approach procedures, and Cat 2, 3 navigation aids. And this is a basic principle. Now with the new concept, there is a slight change. And the first one is the special authorization Cat 1 approach operation, where you see in the slide that we change the decision height is not anymore 200 feet, but is 150 feet. So with the old concept, we are in the area where, first of all, low visibility procedures are required. And for those who are familiar with Annex 14 and with the EASA certification specifications, we know that the obstacle-free zone, for example, is a recommendation for Cat 1 runways and is required for Cat 2 runways, Cat 2, Cat 3 runways. So thinking the same way, we said, okay, if we are below 200 feet, then of course we need an obstacle-free zone. And we need also a Cat 1 instrument approach procedure, but at this, but the decision height, the OCH, should not be 200 feet, but should be 150 feet because you go further down. And the ILS, well, this is something that this requirement is coming from air operations. So you need to have an unrestricted ILS, which is not offset, a glide path of 3 degrees, although some deviations are allowed based on some assessments conducted by the air operators. Since we are below 200 feet with the current technology, we require radio altimeter. So for these Cat 1 runways, we will require also a precision approach terrain chart. And the question was now on the switch over time. The switch over time, we know that there are differences between Cat 1 and Cat 2, 3 runways. And because the aircraft is going further to close to the ground, we followed also the same idea that FAA follows in the same issue, and the switch over time is changed from 15 seconds to 1 second. The good thing is that you don't need to add more lights on a Cat 1 runway. So you can operate with the lights that you have on a Cat 1 runway, but of course the switch over time needs to be changed. On SA Cat 2 is a different story where we go further down to 100 feet. So we go to the limits of Cat 2, and there again the requirement is to have again a Cat 1 runway with the where also we need a specific performance of the ILS. So the ILS should be class 2 D2 to provide adequate guidance down to 100 feet. And if the runway is operating at RVRs less than 400 meters, then you need runway center line lights. Before going further on this, I have to say that the intent is not to downgrade existing infrastructure. The intent is to allow, for example, Cat 1 runways to operate at lower visibilities and lower decision heights without the need to upgrade fully to Cat 2, because there will be the elements that they are missing are complemented by airborne systems. So this is something that you always need to have in mind. Then we have the EFVS operation, where there we don't have many things to say, but we followed the requirements by air operations and from certification. But there are three type of approach of EFVS operations. We have the EFVS. So we have the EFVS 200, where the operation is allowed to a height above threshold not lower than 200 feet. The EFVS approach, where we can go between 200 feet and 100 feet, and the EFVS to land, where there are no restrictions. And the requirements are you can see them on the slide. So for the EFVS 200, so you need an instrument approach procedure, which is at least a non-precision approach. So you have only lateral guidance, but you are not allowed to have a final approach track more than maximum 3 degrees from the extended center line of the runway. And you need either an obstacle-free zone or the VSS is not penetrated. And of course, an instrument departure procedure is established. On the EFVS approach, well, we need similar requirements. We need a straight-in instrument approach procedure. Again, the requirements for the obstacle-free zone or the penetration of the visual segment surface. We need touchdown zone RVR. Low visibility procedures, because we are going down to below 200 feet, and Cat 2, Cat 3 switchover times. And to land, it's what we require for the approach, plus that we need the type A chart and a precision approach terrain chart. And these requirements are coming from as I said, from air operations and from the certification. Then on the another thing that you need to keep in mind, especially for the aerodromes, is that we have not changed the certification specifications, because the current certification specifications meant to support the basic aircraft, and we don't want to change the basic aerodrome design. That's why all these requirements, the new requirements, the add-ons, I used to say, you will find them in the AMC. Yeah. Okay. So on the low visibilities and the SMGCS, we don't have significant changes. basically, we have rearranged the existing text between the implementing rules, EMC, and the guidance material. And I have to say that the existing rule on the, especially on the low visibility procedures, was a very thin rule. So we elaborated further on this, on the objectives. And we don't expect difficulties to comply with this, with the new structure of the regulation. I have to say that all these requirements for the special authorization, CAT1, CAT2, and EFES operations, are enablers. So it's not that all the airports, as of 1st of August, will have to implement these procedures. It's a matter of a decision that needs to be taken by the Aerodrome if they will go this way and they will support this type of operations. It's mainly a business case depending on the airlines and the operators that they are flying there, the systems they have. Our objective is to make sure that if it is implemented in Europe, it's going to be done in the same way. So to avoid to have different practices. This regulation is very, very important, especially for aerodromes which are CAT1, because the CAT2, CAT3 airports, they don't have many things to do. Operations will continue as they are, and they fulfill all the requirements for EFES operations. But it gives the opportunity mainly to CAT1 airports and the other airports which have no precision approaches to allow more flights to come at their airport. So that concludes my presentation, and I'm handing over to Francisco. Thank you.
I'm going to make a radio check with Tom. Tom, can you hear me well? Okay, guys, if you can confirm that you guys are hearing me well through the chat box, it will be appreciated. Okay, thanks. Thanks. So we are a little bit late on time, so I will try to speed up on my presentation. Before that, I invite people to continue posting questions. We have many questions now, but again, please continue submitting your questions. Tom, if you don't mind, I'm going to change the camera because I am speaking through this camera. So you can maintain the two cameras, but I will focus on this camera, okay? Okay, thank you. So all-weather operations main features. We have introduced the operational credits. This is an ICAO concept on aerodrome performance-based aerodrome operating minima. It's nothing new, but I mean, it's nothing new in ICAO world, but it's new for us in EASA in the European context. This doesn't mean that we are substituting the operational credits with and substituting the CAT2 and CAT3. The CAT2 and CAT3 continues to be a standard alone, let's say, a standard approach procedure, not included in the operational credit. We had questions about it, and we will try to answer them later. We have redrafted the regulation to improve clarity, specifically the CDFA and approach band that was not clear. This work was done thanks to the Spanish authority, and Andrew McKedney as well was one of the participants, and it was a colleague in EASA at that time. I don't know if he's listening us today. I would like to thank him for this work and to manage the project originally. And one of his work was specifically the CDFA and the approach band redrafting of the regulatory framework. LVO, license proficiency check requirements, is a move from FCL that we have today in Section 6, Appendix 9, to OPS, where it belongs. It was there in the JAR OPS. and in the UOps, and it was only lately that we have changed to the license proficiency check. Now it's going back to the where it belongs, and ops will be the one required to provide this license proficiency check. So in the FCL and at license proficiency level, there will not need to be a section 6 in the appendix 9. For helicopters, we have enabled the pins. I think this is a quite important element for them. Again, I invite the helicopter people to provide feedback and to give us some questions. We are thinking to have some a new webinar in September in which we may need to detail a little bit more the regulatory framework for helicopters. Please, I invite you to write in the Slido questions and this proposal that I am making to you guys. If you are interested in this, please let us know through a Slido for the second webinar. Operational credits for IFR operating under specific approval. This is also introduced as well as we did for aeroplanes. Next. See. So next element, suitability of runways. This is a quite important element, a new important concept that we have developed. Valentin will explain in detail what it means. Basically, what we wanted to do is to remove the operational demonstration that currently you need to do. We have received questions about it, so you know, maybe this could answer some of the questions that we receive about. Today, as you know, in a Cat 3 environment, you need to, for each runway type, for each runway and aircraft type combination, an operational demonstration is needed for every one and every single runway. So what we want to do is to remove this requirement, and but this cannot be done easily, because when we started to work on this idea, we find out that the certification criteria is not exactly the same as the aerodrome criteria. In other words, when you have a category 2 or a category 3 aerodrome, certified aerodrome, the standards are not the same as the certification requirements. So in the certification requirements, when they operate in a Cat 3 or they perform an auto land, the criteria in terms of pre-threshold terrain, runway slope, variations on the runway slope it may be different from what is required in for the aerodromes. So that imposes a problem, because that means that the comparison between the two criteria needs to be done by the operator. What we did, and I will explain later, and Valentin will explain in a specific example how this can be done. It's not as difficult as it looks, but this will allow us to, if we remove the operational demonstration, that means that charter flights, new routes, and then related to the alternate aerodromes, the airlines will be able to, let's say, to have a better use of the current infrastructure. We can provide more flexibility, and that flexibility will be will imply economical savings, fuel savings, and environmental savings. So, in a nutshell, we're going to allow better use of the infrastructure, we're going to reduce the environmental impact, and we're going to have some economical advantages. Also, this new regulatory framework on suitability of runway will allow to prepare ourselves for future auto-land technologies that are not currently envisaged. So let's go a little bit more in detail on the suitability of runways. We know that 90% of the runways today, we did a study and in Europe is 95, but let's take a round figure of 90% across the world. The new CS issue 2 and you know, and the assumptions of certification in accordance to the CS issue 1 and 2 are within that framework. That means that we can accept that in 90% of the runways, with a documentation check, the airline could operate automatically into that aerodrome. For what we're going to do with the other 10%? Well, there has to be there are several steps, but the first idea is that if you are already operating to an aerodrome and is safe to operate. Therefore, you can use that operational data to confirm and to say and that and credit the fact that you can fly into that aerodrome. So that will be the first case. If you don't have operational data because it's a new airport, it's a new route, your type certificate is a new, etc., then subject to manufacturer statement, Airbus, Boeing, Embraer could say that, okay, this Airbus is equivalent to that other Airbus, and exchange operational data between models from a 330 to a 380, from a 330 to a 320, etc. Also, we allow the use of computer simulations or manufacturer full flight simulator, but fundamentally computer simulations all under the manufacturer. And then if nothing works, it will be an operational demonstration. So we estimate that the operational demonstration with this new regulatory framework will be minimal. So the idea is that, therefore, in a nutshell, the operator use grandfathering rights and use its own operational data, or use other operators' operational data of the same aircraft, as is currently done today. This is nothing new, but also as a new feature, the aircraft, another aircraft models provided and subject to approval from the manufacturer. If this doesn't work, if the grandfathering or the existing operational data, the grandfathering rights doesn't work, then we will do a desktop assessment in which the CS issue 2 and the CS issue 1 is going to give you most of the assumptions of the certification. Then that data can be compared with the IEP, with the airport, and then make a decision at desktop, in a desktop assessment, whether the operation is safe. If nothing of this works, then it will be an operational demonstration. So the desktop analysis is new, so we believe this is an improvement. The previous operational data is as per currently today, although we're going to increase the previous operational data because we allow the possibility, previous aircraft manufacturer statement, to use other aircraft types. And then finally, the operational demonstration that should be reduced due to the statements before. We have today the people that develop the suitability of runways, that help us to develop the suitability of runways. Here are some of them. And if you need to contact them, then you can contact us through a Slido or contact us, and then we will pass your question to them. Entry into force of this regulatory framework is on the 30 October for ops, on the 1st of August for aerodromes, and in the CS8WO is already there. The publication of the AMC and GM will be done this quarter. However, we have put in the ops community the latest AMCs and GMs for ops and FCL. They are available in the EASA website, in the EASA Ops community. We will also, after this webinar, we will include it in this, in the webinar of this, in the website of this webinar. And this is a very latest draft. So we hopefully that you can start sharing this AMC and GM, although it's not official, in preparation to the publication that we will do in June, end of June this year. For the implementation, we're going to help you on that implementation. We have selected today as the first webinar, but we will do another webinar on the 7th of September. Please, it's a tentative, but we will announce this formally at the end of this webinar. And then we are planning one more webinar in October in all-weather operation. And also, for those one interested in fuel, there's going to be another on the 7th of July for fuel, another in the third week of September for fuel, and then around the 26th, if I remember well, in October for the all-weather operation. Thank you very much, and we're going to have a break now. We're going to stay only 5 minutes break. We are a little bit late, so at 35 in 4 minutes we will kick on with the next session of shareholders view. Thank you very much. Okay, guys, welcome back to continue to this webinar. We have now a stakeholders overview. We need to start at 15:30. We're going to start at 2:30 and we continue to 15:30. Stephano is going to start with an explanation of GM1 Espalo VIS 110. Don't worry, there will be an explanation about what it means this. Then we will continue with the previous operational data flow chart from Carsten from LVA Germany, followed by relevant data for the desktop assessment that I already introduced. This is a presentation from Thierry from Airbus. And finally, we will have a practical assessment, an example performed by Valentin. The three first presentation will take roughly about 20-25 minutes, and the practical example will take another 25 minutes. So without more delay, I'm going to give the floor to Stephano. Stephano, you can start sharing while I introduce you. Stephano Prola has spent 18 years in the Italian Air Force as a pilot. He was trained in Canada, UK, and the US. In 1990, he graduated as an experimental pilot at the US Navy Test Pilot School. In his career as a military, he flew 30 different airplanes and helicopter types. And in 1997, he joined Alitalia Express, where he stayed until 2008, holding several positions in flight safety as a flight safety officer, instructor, examiner, chief pilot, etc. In 2010, he was part of the startup team of a regional airline with the position of a director flight operations and aircrew training. And finally, in 2014, he joined IATA. He's now the assistant to the director of safety and flight operations for the European region. He's based in Madrid. He's currently type rated in the 320 and in the ATR. So without more delay, welcome, Stephano. We can see your presentation.
Francisco, and also radio check. Do you hear me?
Stephano, we cannot hear you. Maybe it's me.
No.
Tom, can you confirm if we hear Stephano?
Okay, I see that the other ones are hearing me. So, okay.
Yeah, we hear you. Thank you.
Okay, very well. Good. Thanks, Francisco. Yes, my presentation is gonna a little bit amplify what already Francisco talked about and the following as well. So we're talking about suitability for LVO. Some reason. So where are we coming from? So you're familiar with the present regulation where you have to approach in better weather before doing the low visibility operations. The MPA tried to propose a simplification, proposing to do the landing prior to do the low visibility operations only regular runways. But then through the comments we received, we actually realized that there's no way actually to define what is a regular runway, because a runway could be regular for one type and not the other, depending on the certification and the performance. So this is what happened, and hence the way we went to for desktop assessment. Now you'll see in the SPALO 110 is the one requiring the fly only in suitable aerodromes, and AMC1 is stating is requiring the suitability of the aircraft and of the suitability of the aircraft intended operation at an aerodrome, including instrument flight procedure. So is here the suitability is intended not only for we say the suitability is also including the runway, the navigational aids, the instrumental procedures, the aerodrome procedures, and the runway environment. But more specifically, what we will be talking about, which is a little bit in novelty, is the way we assess this suitability. So we have the three choices, and you're going to see this flow chart, and there's going to be a GM1 that is an introductory guidance material. Once you get to know and understand the system, this is going to become unuseful to you, but maybe for the future operators, people that have not been following maybe this type of workshop, this is going to be helpful for the introduction. So AMC1 is giving you these three choices: previous operational data. So, and we're not going to dwell in each of these parts because that's part of the following presentations. Now, this is only a flowchart to show you that, okay, so previous operational data is grandfathering, so the networking working that you are using now will be, if with some condition, still be useful. The desktop assessment is the novelty. So we have you will have a set of data, and Valentin will going to give you examples, particular example to understand better. If you have data available, there is an AMC that will help you find ways to provide data in an alternative way if you don't find them right away. Anyway, desktop assessment will, if it's successful, then you will be able to consider the runway, the aerodrome suitable, meaning that just by analyzing data, you'll be able to then operate, if that is successful, obviously, in low visibility operations. Finally, if everything fails in a way, you're gonna have you have to do some flights. One good thing though that was introduced, and this is going to be part of partially of a presentation now, but maybe this we are going to have time to talk about more about maybe in the next workshop, but the operational assessment where we introduce a graduation of operational assessment. So there's not one type of operational assessment, not one type of flight for all runners. So that's another good good thing. Obviously, if everything fails, the aerodrome is not suitable. Something has to be done. I want to conclude saying that at first this may appear a little bit complex. At the end of the day, once you get it, it's not so. But I understand, and what is also from the other operator side was also at first a clear request, and I've seen already the questions about it. Why don't we have already the airports declaring this? Well, this is not possible at the moment because, as already Francisco explained, we don't have ICAO standards that are matching the standards for the aircraft. But this is an aim, it's like a medium long-term aim where EASA and also IATA is going to be working with ICAO so that this type of assessment will be alleviated and more clear matching will be done between the aerodrome. So this is conclude, but you'll see more details on everything. So hold on your questions, and hopefully by the end of the other presentation, this is be more clear. Thanks, and I will pass it on to Carsten.
Thank you very much. Now I'm going to introduce Carsten Mild, is our next presenter. Carsten Mild is with the German LVA, the German CAA. He's a flight operation inspector for all German low visibility operators. He's a member of the all-weather operation rulemaking group since 2018, and he's also a member on the ICAO all-weather operations subgroup. Carsten is trained in aerospace engineer, but he's also a pilot, type rated in different. He was type rated and now currently type rated in CS25 aircraft. For me, Carsten is going to be the next Bo Ekerbe. Bo Ekerbe, I will introduce you in a moment, but Bo is the godfather of all these low visibility operations, and I think Carsten is going to be the next Bo, because he has a very good expertise on the LVO, and he's very specialized on this matter. So without any more delay, welcome, Carsten. The floor is yours.
Yes, thank you, Francisco. Do you hear me well? Can you hear me well, everybody? Okay, thanks. So I will start my small presentation thanks to Stephano, who already introduced the three concepts how to state a suitability in LVO. We have seen the first element, which I will be talking about within the next couple of minutes, is the concept of the operator having already LVO operations. So the next 10 minutes is dedicated to operators that are already LVO certified and have a history of operations to a specific runway with a specific type of equipment. But not only, it's also other members should now listen carefully, because that data can be used in circumstances to enhance your network. So I hope this will also be interesting for you. So first of all, we're talking now about the grandfather concept. That's nothing new. It has been in the regulation ever since. We clarified it up a little bit, make it more comprehensive, and included, as Francisco already noted, elements of allowing the data on LVO available to an operator to enhance it to either runways or other aircraft. I will talk about this in a second, how this is going to work. You see here the grandfather, and the grandfather is happy. He's smiling from left to right. He's happy because he's got data he can work with, and I would like to use this opportunity here to address and invite all operators having data available. Please collect them, please share them with others to allow the aviation system to become more cost efficient and more economically and ecologically efficient. So back to the grandfather concept. Basis of grandfathering is, of course, you have a history and a data of history available either from the operator itself. That could be flight data from flight data monitoring sources or flight crew reports. There will be a mandatory flight data monitoring requirement also in LVO for operators operating aircraft with a max takeoff mass higher than 27 tons. They can collect data by flight data monitoring. Other sources might be flight crew reports, etc. So this is basically the concept. A grandfather concept basis on availability of data. Where can the data come from? What kind of data do we accept or do we have in mind? Well, it can be the data of the operator itself. Apparently, might be a situation in which the operation has ceased a couple of years ago to a specific runway, and the question is now, can we again put that aerodrome into our route manual, and maybe data can be used under the conditions set out here in the new regulation. But it's not only the data from the operator itself that the operator can use. The operator can also use data from other operators. That might be interesting to a lot of airlines being organized in groups, operating similar aircraft types. I have seen a lot of applications on this. The data also could come from the state of the aerodrome. We have this case, for example, in the US, where the FAA is providing suitability information. However, that's the only one I am aware of on the whole globe, but we don't want to miss it. We put it in the new rules, so you can take advantage of that data being on the market. Data could also come, at least it is possible that the data might come from a competent authority issuing the operator the LVO approval, so it's the competent authority for that operator. And last but not least, maybe I should have put it a little bit higher in the listing here. Data can, of course, always come from the type certificate holder of the aircraft, that is the manufacturer. Now, this is where the data you could use can come from. We think that's a pretty good list of all entities being able to make such a statement about suitability. What can the data be used for? What is the conditions under which you can use the data? Well, first of all, it's all runway centric. So if you have data of operation to a specific runway, then this data is only good for that runway. That is the idea of grandfathering. That is the idea of previous operational data. So this is one of the restrictions you might have using the grandfathering data. And it's not only that it is restricted to the runway, it is also restricted to the condition under which the last operation or under which the data has been collected. So if there are any changes to the runway itself, to the environment of the runway, or even the navigation facility, you would have to assess. We don't say it's impossible to use it, but you would have to assess these changing conditions from the time where you took the data, where you collected the data, and to the time when you used the data for other purposes. That's the first idea. The second idea is, of course, low visibility operation is not just a runway. It's a collection of equipment being used, procedures being used. So the data you have collected and the operation you're looking to use it for need to be compatible. I'll show you a little bit about this in the next slide, but you cannot. You need to have a certain compatibility between the operations from which you collected the data and for the operation you want to use the data for. And of course, meanwhile, there shouldn't have been a safety problem. I just give an actual example. In the US right now, there are being issues with interference from the radio altimeter with 5G radio signals, telephone signals. That would be an example for such a concern. That always has to be taken in consideration. So let's take a look at the way how we present compatible LVOs if you have data on previous operations. The idea is to allow operations which are based on the same equipment for the same level of automation or a lower level of automation, and for the same category of operation or a less performant category of operation. Now we decided not to put all these yellow words in the rules, but rather to come up with a straightforward table. And I would just like to present you a table which will be in the rule as with which you will be able to assess whether the data you have available are suitable for the intended operation you're planning to. So the yellow arrow represents the way the data is being used. It's being used from the right to the left. And I choose some examples that might be of interest for maybe the greater part of the audience, because it's the operations which are presently, at least to my understanding, the most interesting ones. So let's just quickly look at the table. You will to the upper left, you will have a category 2 certified aircraft, which doesn't have auto land, and you need to operate category 2 with a manual landing. Then you can use data from aircraft being having operated either with that manual landing, that's the first row, or either with automatic landing. It's not possible the other way around. As you can see in the second row, you cannot credit for a Cat 2 automatic landing operations coming from an operation with a manual landing, because the level of automation has increased. And as example, for the most restricting use of previous operational data is the last line as an example. For a Cat 2 automatic landing, only data stemming from a Cat 2 automatic landing operation is compatible to be used. Now, please also keep in mind if you're changing categories, for example, in the first part, you're also changing the location of the decision height. You reach the decision height much more farther out. So that would have to be taken into consideration when using data from an operation that has a different decision height or a different location of the decision height. And of course, if you change the navigation type, you need to assess with respect to the classification of that system. Last aspect is what can we credit the data we have to what aircraft can we credit? Francisco has already mentioned that we have enabled this to be more permissive, the data, so it's not only restricted to the very same aircraft. The new rules will allow a credit within the make and model. So for example, that is the first row, you would have an Airbus 321 of a specific series. You can credit this operation to the specific runway to all other aircraft in the A320 model. Same goes with the 737. If you have a MAX data on the MAX, you can credit it to all series aircraft in the 737 model, unless, here's another unless the TC holder itself restricts sorry, not the TC holder, unless the entity providing the data puts further restrictions on the data. Now, that could be the state providing data, the TC holder, or the other operator could also say, well, we don't want you to use that for that type of operation. We want to restrict that. So it's possible that you would have such restrictions on the one hand, but it gives you, as a basic understanding, it gives you the possibility to enhance your operation within the model. So that's the first issue. The second issue is if you have the type certificate holder provide you a statement with similarity, you can expand your previous operational data experience to other aircraft models. I am aware presently that this is possible, for example, within the A320 family. Even maybe, Jerry can say something more maybe on this later on, to other aircraft models. And also from Boeing, we are aware of cross aircraft model crediting based on a statement of the manufacturer of the TC holder that the equipment and the behavior of the system is equivalent, is similar. So this is basically about the information on previous operational data. We conclude maybe with a slide showing you a workflow, how to assess whether you can use data for your specific operation, for your specific combination between the aircraft type and the runway end. We start at the upper left corner, orange, and you either end up in the green box or in the red box. So first of all, let's start with the first question. Do you, as an operator, have your own data? Yes, you can continue all the way down, considering the aspects we have talked about in the presentation just a couple of minutes ago, or you take the right turn here. You don't have own data because you are a new airline that has been established within a group of other airlines that have the data available. You can use that, and you go back from the other data available box to the compatible LVO and do the same assessment. And given the circumstances, you will end up in the green or in the red box. So this is a recapitulation of how to use the data. Thank you for your attention, and to the next speaker.
Carsten, thank you very much. Now our next presentation is going to be about, with Thierry Bourreau. Thierry, you can start sharing your screen and connecting your your computer and your camera. Thierry is an expert on auto-flight system in Airbus. He's been in Airbus for more than 22 years. He's going to be and before that he was responsible maintenance in different camos. He has a spectacular CV. I'm going to focus only on the in Airbus, which is he was responsible of the development of the autopilot for the Airbus 380. And as I said, he then had different positions, and now he's an expert on the autopilot system. So 22 years in Airbus, one of the best experts both for ops, but also for Carl, my colleague in certification. He did a wonderful job there in the CS and updating CS issue 2. So welcome, Thierry. The floor is yours.
Thank you. So I will try to catch up on the agenda. So I want to introduce a little bit about desktop assessment, and you'll have a complete illustration later on about how to perform this. And this presentation, I've prepared it with my colleague from Boeing, Beshara. So what we said, it's not only the Airbus voice, but it's also the Boeing ones. So what is this is new desktop assessment, and how do we see it should be applied? So we believe it should be applied for new aircraft model and series that are introduced in the operation. It will be also possible to apply it for a new runway that for an existing fleet in operation. And also, it could be applicable to a new system which is going to be used for low visibility operation. So, as I said, you understood, desktop assessment is something really a novelty. It requires data from the TC or STC holder. We believe desktop assessment is something that can be used for majority of runway. However, current published AFM does not contain the relevant data, and I will explain a little bit what is missing in the next slides. And also to say that already certified aircraft, we are not required to update AFM, so most probably existing the fleet and existing certified aircraft won't contain in the future the required data. Try to see the next slide. Oh, here we go. So as I said, current AFM does not include all the necessary data to perform the desktop assessment. So if you intend to go this path, you must ask your TC or STC holder the requested data, which is needed to perform this assessment. We expect similar aircraft to have similar kind of restriction or similar criteria. So don't expect many difference from one aircraft type to the other aircraft type if it's the same size. Of course, between an A380 and a BizJet, there won't be exactly the same criteria. But between the same aircraft type, we expect similar criteria. And that is to say, desktop assessment is a novelty. If you don't have this possibility, you can still use the old way, and we won't develop much on this old way, but you can still go through the operational assessment. This is still an option possible. What we have improved is that we have provided some kind of scale approach to do what is necessary, only what is necessary. This regulation will allow future system and future capacity to be easier to develop and to operate. So I would say the current regulation is well suited for future system. That it will be easier. We will have easier access to relevant data. Most of them, but maybe not all, will be part of the FM. And that's all. I would just to finish before to pass to the next audience. Be ensure that we've been with Boeing colleague very focused on safety, so and also on efficiency. So make sure that we do only what is relevant and not do things just because they are need to be done. So we really support the approach of desktop assessment for cases where it's obvious that doing one flight is not really relevant. However, there will be some remaining cases where it remains relevant. Thank you, and if you have questions, don't hesitate, we will answer them.
Thank you very much, Thierry. Of course, I invited the people. We have a very good expert. Not so many times we have the possibility to talk directly with an expert like Thierry. Beshara from Boeing is also here, so I invite you guys, those one interested in certification matters, original equipment manufacturer, etc. Don't hesitate to put those questions in Slido. So I invite you to do that. Now the next presentation, you have, Valentin, you have a little bit more than 20 minutes. It doesn't matter if you delay a little bit because we have 15 minutes firewall for breaks, so you can take some of the minutes if you need. Valentin Minning is our next presenter. He's going to do a long presentation now with a particular example, a real hand operation on this regulation. He joined the European Air Transport, so DHL, back in 2019. He's a flight operation engineer in that operator, and his expertise is mainly on the LVO topics related to the whole AET fleet since then. With no more delay, I give the floor to Valentin. Valentin, the floor is yours. We see your. I think now we can see you.
Okay, thank you, Francesco. I hope the sound is clear for everyone. As we faced some issues before, please don't hesitate to write in the chat if you have any trouble to understand what I'm saying. So thank you for the nice introduction, Francesco. Yeah, as an operator, the desktop assessment will be new for most of the operators. That's why I think it's a good finish for this set of presentations to show some practical examples for the desktop assessment we will be facing. So just to have an orientation, you know this flowchart from Stephano. We are here in the AMC3 for the desktop assessment, meaning in the case that the previous operational data assessment was not successful or could not be carried out, you will go into the desktop assessment to check the suitability of the respective runway for your aircraft. I will also, I think Francesco, you mentioned it before, or Thierry, give a quick or a very brief outlook if the desktop assessment fails to the operational assessment that we will have to carry out then. It will be at the end of my presentation. As it was mentioned before, it will be part or a major part of the second webinar in September. However, just to not leave you hanging with an example of a failed desktop assessment, I will give you a quick outlook how the operational assessment could look like. So the desktop assessment, I will provide you several examples on how a desktop assessment can be carried out. I will focus mainly or solely on the pre-threshold terrain assessment and the landing system assessment area. These are two aspects will be new, and I think most of the operators will be doing it for the first time. So I think it is a good idea to focus on these two key aspects of the desktop assessment. As Thierry mentioned before, the current AFM do not contain all the relevant data that you may need for your desktop assessment. So we contacted Airbus for our A300 and A330 fleet to provide the additional data, and they gladly delivered it to us. So that's why my examples I will be showing you will be based on our Airbus A300 and A330. It's interesting because these two aircraft types have significant differences, as the A300 is pre-CSAVO certified and the A330 is CSAVO certified. So I will come to that on a later stage. Let's start with the two considerations I was talking about for the desktop assessment. You have the pre-threshold terrain. It's yeah, kind of self-explaining, I would say, the name. It's the ground profile under the approach path up to the runway threshold. The distance you have to consider for your assessment should be usually 300 meter unless it is otherwise stated by AFM or the TC/STC or the state of aerodrome or competent authority. So let's go directly to an example for the pre-threshold terrain criteria for an Airbus A330, which is, as I mentioned, CS-AVO certified. I extracted a little part from the CS-AVO 131 about considerations for the certification specifications of a runway. And with this criteria given, Airbus developed let's say a cone defining an upper and lower pre-threshold limit of your runway. So this is an example of data that can be provided by the STC holder, or the manufacturer, in this case, Airbus. It's a really nice example in my eyes because you have a very clear and detailed display of your limits that you have to fulfill. And with this, you can directly go into your desktop analysis, desktop assessment for the pre-threshold terrain. Further than the pre-threshold terrain, we have the so-called mean slope of the landing assessment area. This will be, I think, very new to kind of everyone. It was for me as well. So it is defined by a mean slope that is the connection line, let's say, of the threshold elevation and the runway profile elevation at 600 meter beyond the threshold. So it goes into the landing area, into the touchdown zone area, and is clearly defined. You see it here with the red line of the connection line of the threshold and 600 meters into the runway, the ground profile. Please don't mind the scale here. I'm quite aware that a runway won't look exactly like this. This is just to have to give you a better understanding and a better illustration of this. Airport data to be used, airport data that we need for the assessment. Primary source for the pre-threshold terrain is the precision approach terrain chart, of course. In there you can you have usually the terrain from at least 900 meters up to the threshold, which then fits the criteria you need to consider for the pre-threshold terrain assessment. Also, there are alternative ways, of course, to gather this information. And one is, for example, that you can use your own FDM data from manual landings that you performed on this respective runway. It's also a possibility you can use, but I think the primary source, as mentioned, should be the precision approach terrain chart. And for the assessment of the landing system assessment area, it appears, or it's quite obvious, that the aerodrome obstacle chart is the primary source here, because in there you have all the characteristics and all the variations of your runway and the runway slopes important for the assessment area. It's important, just one advice maybe, that some states that also, of course, publish the aerodrome obstacle charts may include more detailed information about runway slopes or the characteristics of the runway itself in their AIP text part. So it's definitely worth checking this out as well, because in the end, sometimes we have more information in there, but it just happened to me for one or two states, but it's worth a shot. So the pre-threshold terrain assessment for an A330, please always keep in mind that we are talking about an A330 here. So what I did is I just transferred or just applied the cone that I showed you before that was provided by Airbus to an example here of a pre-threshold terrain. This is actually a very easy way to do it. And as Thierry and the others mentioned before, most of the runways will fit this criteria of the CS-AVO certified aircraft. And for example, Airbus applies this criteria for all their fly-by-wire aircraft that are CS-AVO certified. So this would be applicable for an A320, 330, 340, 350. You wouldn't have a difference here for the desktop assessment, the criteria for the pre-threshold terrain. So, of course, in this case, it's clearly visible that the pre-threshold terrain is within the criteria and fulfills then the desktop assessment for the pre-threshold terrain initially is successful. But we need, of course, the landing system assessment area as well. It will be some examples following the next slides. A second example, and I use this because it is actually a terrain with quite significant variation, so a quite significant rising terrain, but also just to give you an idea how that this assumptions for the Airbus fly-by-wire aircraft are pretty stable, and really most of the runways will fit in there. So even terrain that seems to be more complex usually stays within the limits of the fly-by-wire Airbus CSAVO certified Airbus cone. But of course, I had to search a little bit in our network, but there will be runways that might fail one or the other criteria. So in this example, we have clearly visible that within the first 60 meters up to the runway threshold, the criteria of the maximum allowable 0.5 meter variation is failed. So in this case, you would have to consider that the desktop assessment regarding the pre-threshold terrain for this particular runway failed or is not successful. Now, I know we are maybe a very special operator, as we also operate a very good old aircraft with the A300, but still there are several operators that do the same. So it's an aircraft that was certified pre-CSAVO or has not been certified according to the CSAVO certification specifications. So therefore, you have different criteria for the pre-threshold terrain assessment. And as you might see now, most of the runways will, of course, hurt this criteria for the A300. So you only have the 0.5 meter allowable variation, which in my eyes depends on or is due to the accuracy of the radio altimeter from 300 meters up to the threshold. So as you can imagine, there will be many runways, of course, failing this criteria for an old aircraft like the A300. Just a random example here, that this would, of course, also fail the desktop assessment for an A300. However, I will give you an outlook, as I mentioned, how to continue on this stage for this example of an A300. Let's go to the assessment of the landing system assessment area slope for Airbus aircraft. This is applicable for both aircraft types, fly-by-wire or not fly-by-wire, so CSAVO certified or pre-CSAVO certified. For the assessment of the landing system area, you will have no differences. The characteristics are clearly also stated by Airbus that the mean slope should not exceed a total of 0.8%, and especially this will be new, the deviation of the runway profile line and the landing system assessment area, the mean slope of the landing system assessment area should not exceed 1 meter. So how does it look like? Well, here you have the connection line, so the mean landing area slope. You have the 1 meter plus and minus variation, and your runway profile has to stay within these limits at any time, up to the 600 meters. So this will be, of course, something you have to take into account when you assess the landing system assessment area slope for Airbus aircraft. Let's go to an example. This is the characteristics of a runway with, let's say, all the details you need. Not every AOC chart or not every information regarding the runway looks like this. This is a very nice example because you have all the information you need to assess the 300 meter area already given. So you don't have to use a scale or anything else. So you can go directly here into your analysis. So the consideration always starts from the runway threshold. So in this case, it's 2.44 meter for the runway 06 right. And the displayed elevation of the respective slope changes and the distance between them can be used to calculate the mean slope of the landing system assessment area. There's a bit of work you have to do, a bit of calculation, but it's possible, and you can also basically use Excel to do it. That's how I did it, for example. You can really display these slope characteristics of the runway into Excel up to the 600 meters. And in this case, you can calculate your mean landing slope, which is 0.14% in this case. And also you can clearly see that the runway profile stays within the ±1 meter limits at any time. Here, the runway profile line, the mean slope of the landing system assessment area, and the two maximum deviation lines that define the area which the ground profile may not extend. I have a second example, of course, because I wanted to show you again an example where this criteria might fail. So it's also a nice example. So I always please always keep in mind in case of a displaced threshold. So you start your consideration always at the runway threshold. So please keep that in mind and double check that at any time you are making a desktop assessment. So let's have a look. We display the criteria or the characteristics into our Excel file, let's say. You'll see that the deviation from the runway profile line from the LSAA slope is failed, is more than 1 meter. And although the overall slope is roughly 0.1%, the Airbus criteria for the deviation is hurt. So this would mean that your desktop assessment for the slope failed. As I mentioned before, if either the pre-threshold terrain analysis or the slope analysis fails, you can do still the operational assessment. As Thierry mentioned also before, it's more detailed, and there's more details in terms of the complexity of a runway, of the consideration, how many approaches you would need for a certain runway, and in which conditions they should take place. So it's a very clear guidance in the AMC4. It will be for the evaluation of a runway complexity and to determine your number of flights and the conditions they should take place. So the pre-threshold terrain and the slope of the landing system assessment area will define the complexity of the runway. But as I mentioned, this will be a key point or a focus on the next webinar. I would just give you a first insight for two examples I mentioned before, how you would proceed after the desktop assessment failed. So let's go back to our first example for the A300, where the pre-threshold terrain criteria were not met and therefore the desktop assessment failed. So you remember this, of course. And I just will present you an extract of the criterias or of the criterias, how a runway complexity is described in the AMC4. So for the pre-threshold terrain criteria, this is for a so-called moderate runway. So you will have simple runway, moderate runway, complex, and very complex. So you have 4 different categories. I will focus now on the moderate runway, which is defined for the pre-threshold terrain by a ±1 meter variation within the last 60 meters prior to the threshold, and up to the 60 meters, a rising slope less than 7% or a moderate seawall not exceeding 3 meters. For the slope criteria, it's pretty straightforward. You have the maximum allowable of ±1.8% of the total slope, and you have a less than 2 meter allowable variation around the mean LSAA slope. And the program that would be the result if you declare this runway or you assess this runway then as moderate will be one approach usually in the intended operations in the meteorological conditions that will also be described in the AMC4. So let's take this moderate runway cone I was talking about and apply that to the example 1 for the A300. And you see now this runway or this pre-threshold terrain fits into this assumptions or this criteria, meaning that the pre-threshold terrain could be declared as moderate. Now let's go back to the landing system and assessment area. So you also remember this example that failed our slope criteria because it exceeded the 1 meter deviation from the mean slope of the LSAA. So just to let you know again, what are the criteria for a moderate slope? Plus minus 0.8% and less than 2 meter deviation from the mean landing system area assessment area slope. So let's apply this here, and you will see that your assessment area of the runway stays within these limits, as of course your mean slope hasn't changed, but your deviation for the moderate runway is 2 meters, and you fulfill that, meaning that you meet the criteria for a moderate runway. If you combine, let's say, if the pre-threshold terrain I was showing before and this slope would be the same runway, you have the two criteria for moderate fulfilled, and then you have a moderate runway, meaning in this very example that you only need one landing in Cat 1 or better weather conditions to check or to prove your runway as suitable for your LVO. So let's come to my conclusion. The desktop assessment, this is very important, compares aircraft data and runway characteristics to determine the suitability of a runway for LVO. For the CSAVO certified aircraft, most of the runways will have a positive outcome in the desktop assessment, and therefore you won't need any more landing in Cat 1 or better weather conditions, so you can directly go into your respective Cat 2 or 3 operation if the desktop assessment is successful. Aircraft related data that you will require is AFM data completed by additional data from the TC or STC holder, so let's say the manufacturer in this case. It is a problem that the current AFM do not provide this data, but I encourage you and I advise you to really use the usual channels to your TC, STC holder of the respective aircraft to demand this additional data for the desktop assessment that you need. The aerodrome data can be derived from the precision approach terrain charts and the aerodrome obstacle charts. I mentioned before there are alternate means that you can also agree with your competent authority on, or you can use, of course, FDM data for the pre-threshold terrain. But usually, in most of the cases, you will need this two types of airport charts for your desktop assessment. If the desktop assessment is not successful, it does not mean that you cannot carry out LVO at all. You will have to go into an operational assessment, as I was showing you before, and use, let's say, the old ways of approving a runway for LVO. And the program of the operational assessment, meaning the number of flights and conditions, they depend on the complexity of the runway, and they will be very, very detailed and clearly stated in the guidance material for the AMC4. And I think it will be another at least 20-minute session for the next or the second webinar taking place in September. So thank you very much for your attention. I know it was the last presentation and maybe a lot of things to take in. But this presentation will also be, of course, shared, and I invite all the other operators to check their runways, to check their network, perform some desktop assessments as soon as you have the drafts of the AMCs and available, and share your experience, please, with that. So thank you very much again, and Francesco, I will lead back to you.
Thank you very much, Valentin. You know, clearly you are German, man. I mean, exactly spot on 1530 as scheduled. So thank you very much for that presentation, and thank you very much for being on time. So I'm going to share with you guys my screen. We have a 15 minutes break to stretch your leg, take a coffee, and then we are back with a number of questions that we receive at 45 past. The panel discussion and questions, the panel discussion question will be at 45 past, as I said. We have a number of participants. Stephano Prola, I already introduced to you guys, Stephano. Thierry from Airbus, which I already did. We have Walter, Karsten, Milt from LBA. We're going to have Bo Eckerve. I will introduce Walter and Bo later on. Beshara is a pilot from Boeing. I will introduce later on. And Valentin as well, Alexander, Jens from Lufthansa, which I will introduce. The idea of this panel is to have a discussion, answering questions, but at the same time, we have a exchange of opinion regarding this regulatory framework. I'm going to ask each one of the panelists a couple of sentences. So you have the break. Think